In this video, I will be sharing to you how to derive formulas to be used in the topic kinematics. Under kinematics, you have uniformly accelerated motion, the free-falling body, and the projectile motion. And these are all topics that you will be encountering in the subject physics or taking the subject physics. Anyway, these formulas that this derivation of formulas that I will be sharing to you can actually be found in some physics books, and I think there are also some videos about this. And then I just would like to try to show you, if not similar, to how they derive the formulas in other references and videos. Okay, now so these are the formulas that will be used if you are going to solve problems regarding kinematics, and there will be three main formulas that we will be discussing here. The first formula is the distance is equal to velocity times time, and this is actually being used if you are having constant speed or velocity. And then another formula is the average speed or velocity, which is Vf plus Vi over 2. And then the third one is the formula for the acceleration, which is Vf minus Vi over time. For our legend, the d, of course, that's the distance, and then the v is the velocity, in which we have two types of it. You have the Vf and the Vi. So Vf is the final velocity, and then the Vi is the initial velocity, and then the t stands for the time, and then a stands for the acceleration. Now, in terms of the velocity and the speed, so you might interchange them, but the reality of that, speed is different from the velocity in terms of them being quantities, because speed is under scalar quantity and velocity is under vector quantity. And I hope you know the difference of the two. And if you don't, then this is the difference. When you say scalar quantity, these are the quantities that have magnitude only. But for the vector quantities, these are the quantities that have both the magnitude and direction. For example, when you're asked about how far have you traveled, so you could just tell, or let's say, you could just tell 5 kilometers, and that is referring to a distance. And then if you are going to answer distance, like 5 kilometers going north, so that's already a displacement, because distance is under scalar quantity and displacement is under vector quantity. And if you want to know more of this, you can just read on some references. Okay, so again, these are the three main formulas that we're going to utilize to get the other formulas that you can use in the problems or in dealing with the problems under kinematics. Now let us start deriving the other formulas. Okay, have a quick glance now before I'll remove them out of your sight. Okay, thank you. Now let me rewrite the formulas again. So I will be having the formula here for the acceleration, which is AVF minus VI over time. And then let me have it at the middle, the average velocity, which is VF plus VI divided by 2. And then here, the distance, which is equal to velocity times time for having constant speed. Now let me start with this. Acceleration is equal to Vf minus Vi over time. So to derive the other formulas from this formula alone, so let us have the cross multiplication. So if we are going to cross multiply this, then we will be having AT is equal to Vf minus Vi. And then from this, AT is equal to VF minus VI, we can now get the first derivation. If you are looking for the time, so if we're looking for the time, from here, divide both sides by A, divide this by A, divide this whole thing by A. So we will be having VF minus VI over A. And then, if you want to solve for the final velocity from here, VF from here, we only need the VF, so that's why this VI will be transposed on the other side, and that will give us VI plus AT. And then, the third one, if we are looking for the VI, so again, from here, to solve for the VI, transpose the VI here, and then transpose the AT here, then we will be having VF minus AT. There you go. So from this first formula, which is acceleration equals VF minus VI over time, and then by cross multiplication, you will get the other three derived formulas, which you can use in solving a problem. Now, let us go to the other side. I will have now this one. D is equal to VT. Okay, the first formula that I will be having is by, for the V, I will substitute it with the formula of this. So I will have D is equal to, so instead of writing V, I will substitute it with this. I'll have VF plus VI over 2. And then this T here will be substituted with the T here. And that will give us VF minus VI over A. Now, from this result, we are going to multiply the numerator by the numerator and denominator by the denominator, so that you won't be confused on how am I going to do this. Let us have a recall of the difference of two squares. Okay, for the difference of two squares, I don't know if you can still remember this in algebra. This is actually one of the methods of factoring polynomials. Let us have an example, which is x squared minus 4. Now, this is under difference of two squares. From the word difference, it is minus. From the word two squares, because both of the terms have square roots. And x squared, there are two x's. For 4, there are two 2's. Therefore, the factors are x plus 2 and x minus 2. And then if you are going to do the checking, you must go back to x squared minus 4. And to do the checking, let's see. Let's check if we can go back to the original problem. So multiply this, 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 and this. So x times x, so that's by checking. So x times x, so that is x squared. X times negative 2, that's negative 2x. 2 times x, so that's positive 2x. 2 times negative 2, that will give us negative 4. So x squared, negative 2x plus 2x is 0, minus 4. There you go. So I want you to pay attention to this. X plus 2, x minus 2, if we are going to perform multiplication, this will give us this one, the x squared minus 4. So if we're going to look at this, the shortcut is this. If they have the same first terms, the same second terms, but they differ at the signs between them, then you can have x times x, x squared, positive times negative, that's negative, and then 2 times 2, that's 4. Let me repeat that. X times x, that's x squared, positive times negative, that's negative, 2 times 2 is 4. You can only do that if, again, they have the same first terms, they have the same second terms, and they only differ at the signs between them. Okay, let us now apply this to this one. Look at this. They have the same first terms, VF, VF. They have the same last terms, VI, VI, and they only differ at the signs between them. Positive here, negative there. So what will happen? It should be similar to this. Is that very clear? Now let us apply it. So this will give us Vf times Vf, so that is Vf squared, minus Vi times Vi, so that is Vi squared, all over 2 times A, that's 2A. There you go. So we now have another formula for the distance given the Vf, the Vi, and the acceleration. Next, another one. Okay, so same steps. D is equal to Vt. Let us now change V with Vf plus Vi over 2. Then it will be multiplied by time. In this case, what I would like to do is this. The Vf here, this one, the Vf here will be substituted with the value of the Vf there. So again, this Vf will be substituted with the formula of the Vf here, or the value of the Vf, which is equal to Vi plus 80. Okay, let's do that now. So D is equal to the Vf to be substituted by Vi plus 80 plus Vi, of course. So this one is the Vf from here. Then plus the Vi all over 2 times T. Then, again, the basics of algebra. Vi plus Vi is 2Vi. Then, plus 80 all over 2 multiplied by the T outside. Again, Vi plus Vi is 2Vi. Now, 80 is added because they are separated by plus sign. So we are not multiplying. Again, we are not multiplying. We are actually adding. Then there you go. Then after that, multiply T or distribute T now to each term inside the parenthesis. And that will give us D is equal to 2 VIT plus 80 times T. That will give us 80 squared all over 2. You can already use this as a formula. But again, you might be confused because this is not how it looks like if you're going to check physics books. Then let us simplify that further so we can separate them. Again, let us try to recall your elementary mathematics. And in elementary mathematics, for example, so LMath. For example, if I have here 5 plus 4 over 3, this can be also equal to 5 over 3 plus 4 over 3. So again, 5 plus 4 all over 3 can be equated to 5 over 3 plus 4 over 3. So you can separate the numerators since they have the same denominators. And I hope you know already the rules in adding similar fractions. If they have the same denominators, then you can already perform the operation using the numbers in the numerator. So again, if I will have your x minus y all over z, that can be x over z minus y over z. Or you have a plus 3 all over b, that can be a over b plus 3 over b. So this is actually a concept in elementary mathematics which we are going to apply here, because we have here a binomial numerator and then we have a denominator. So by applying this one, so this will give us 2 VIT all over 2 plus AT squared all over 2. And of course, the 2 and 2 here is equal to 1. So finally, we now have this equal to VIT plus AT squared over 2. But in some references, it is being written this way, VIT plus 1/2 AT squared. So they are just similar. Did you get it? So again, I only have 3 formulas. Okay, I only have 3 formulas. Acceleration is equal to Vf minus Vi over T, the average speed Vf plus Vi over 2, and then the Formula for the distance, if the speed is constant or velocity is constant, is v times t. With only these three formulas, you can already derive the other formulas. And let's start with this. By cross multiplying, you will get this one. And then by applying the concepts in algebra to solve for the VF, then to solve for the time, divide both sides by A, you will get this. And then from here, to get the VF, and then from here again, get the VI. And then proceeding to distance is equal to VT. So D, the first one, D, substitute V with this one, substitute T with this one. You will get this. Okay, so let me put them inside the rectangle. So we have here 1, 2, 3. 3 formulas derived from this. Then from here you have this and this one. So this is supposedly an OR. There you go. So from A is equal to VF minus V over time, you can get the 3 other formulas. And then from D is equal to VT, just manipulate the V and T here. So the first substitution for V is this one, and the substitution for T is this one. So that's why you should do this first, so you can derive the formulas of the 2D's here. And then for the next formula for the D, substitute again V with this, and then retain T, and then with this, substitute VF with this one, VI plus AT, then plus VI. Of course, you have to retain the VI and the T. And then perform algebra, elementary mathematics, then until you will get this formula. So let me put here a borderline. There you go. So there. With this 3 formulas, you can get the other derived formulas. You will only have difficulties in deriving formulas if you have a very poor background on algebra and elementary mathematics. That's why I advise that you should be always remembering every detail, every small concept, every basic concept, fundamental concepts from elementary mathematics and algebra. Because these concepts, these basic concepts that you have learned there can be utilized and can really help you to understand how these mathematical problems are going on. I hope I made myself very, very clear in that case. So again, have a quick glance on this. So going back, let us have a review. So in the subject physics, one of the topics is about kinematics, and kinematics have lots of formulas to memorize. And for you to get rid of memorizing lots of formulas, I will now be teaching you to derive formulas by just using these 3 main formulas to be used in these 3 concepts or 3 topics under or subtopics under kinematics. And then from these 3 formulas, there you go. From those 3 formulas, you can derive 3 from here and then 2 from here using the other derived formulas. So there you go. So that ends my video on deriving formulas for physics. And for the next videos, I will be solving physics problems using these derived formulas. But I just would like you to know that in some cases, for my personal opinion, in most cases in solving problems in physics, you don't need to derive formulas. You can actually use this, and then again having those basic concepts, you can already answer. For example, if you're looking for the VF, you don't need to derive the formula for the VF to solve the problem. You can just directly use this, and then from there you can already solve the VF. And that is what I'm going to show in my next videos. So there you go. Good luck in trying to be familiar to this. So I hope you have already understood what I really mean in deriving formulas. Thank you very much, and hope to hear from you or see you again. Thank you.